Okay, Puneet, let's see if we can answer your question. So here's the question. A ball falls vertically onto a floor with a momentum p, bounces repeatedly. If the coefficient of restitution is e, then you need to compute the total momentum imparted by the ball on the floor. So just by looking at the problem, there is a coefficient of restitution, which means it's an inelastic collision. Okay, so the ball falls with a certain momentum, bounces back, and the absolute value of that momentum is going to be lower than the initial momentum. Yes, simply because coefficient of restitution is less than 1. And this will happen several times till the ball comes to rest. So just by visualizing what's happening physically, it should be obvious that this will be some kind of a series. The first impact, second impact, third impact, and so on and so forth. And it needs to be some kind of a series that you can sum to infinity. That's kind of what the problem should tell you straight away. So let's see how to approach it. So I've written it out here. I'll just read it through for you. So the initial momentum of the ball here, is p. If you apply the definition of coefficient of restitution, if the initial velocity of the ball was v, then the velocity of rebound is going to be minus ev. Okay, multiply by mass on both sides, which means that the final momentum after rebound is equal to the initial momentum before rebound, which was p, times minus e. And that's what we've got over here. Now, the change in the Earth's momentum is going to be the opposite of the change in the ball's momentum, because momentum is conserved, right? And therefore, so that's minus sign is because of this minus over here, and in brackets this is the final momentum which we computed over here, minus p, which was the initial momentum of the ball. And therefore, if you compute the momentum, works out to p into 1 plus e, change in the Earth's momentum after the first impact. Let's see what happens after the second impact. Now the ball will bounce back, with minus ep. It will rise to a height and then fall back again, and its velocity at impact will be the same as the velocity with which it started upwards, except that the sign would have changed. So the initial momentum now becomes ep. Final momentum is going to be, by the same logic as earlier, is going to be minus e squared p. Same logic as in the first step. And again, if you apply the same logic for change in Earth's momentum, it's going to be minus of minus e squared p minus ep. If you simplify this, this will work out to ep into 1 plus e. Let's do the same logic for the third impact. Again, initial momentum, as I described in the second impact earlier, is e squared p. Momentum after the impact is minus e cubed p. Same logic as earlier. The change in the Earth's momentum, therefore, is minus of minus e cubed p minus e squared p. Simplifying, this works out to e squared p into 1 plus e. Okay, so there's an infinite series being formed, as you can see. Now, if you kind of add up this series, this is from the first impact, which is p into 1 plus e. This is from the second impact, which is pe into 1 plus e. This is the third impact, which is pe squared into 1 plus e, and so on and so forth. So this forms a infinite geometric series where the first term is p into 1 plus e, and the ratio, common ratio, is e. As you can see, the first term multiplied by e gives you the second term, and the second term multiplied by e gives you the third term, and so on and so forth. The sum of such a series, infinite series, would be p into 1 plus e divided by 1 minus e. I hope this answers your question. Let me know if you still have problems.